Today we are going to start our experiment number 10 in the course subject Industrial AC Machine. Myself, Professor SV, Head of the Electrical Engineering Department, JSPM, Bhimrao Sound Polytechnic. Is to conduct direct load test on single phase induction motor to determine its efficiency, then speed regulation and plot the performance curves. The title is already seen. The conduct direct load test to determine efficiency and speed regulation on single phase induction motor and draw the performance curves. Here relevant program outcomes: PO2 discipline knowledge, PO3 experiments and practice, PO4 engineering tools and PSO electrical equipments. Means by performing this practical, student will acquire the relevant program outcomes. Now here the expected result is shown. The graph is on x-axis output in kilowatt, means motor output, and y-axis speed. Then second efficiency, symbol is eta, current I2 and power factor. Here the output power versus speed curve is shown here. As the load increases, means output increases, the speed of induction motor decreases. Now second efficiency versus output power. Efficiency goes on increases and after a maximum value it going on decreases. So likewise the performance is determined here. Here is the circuit diagram. Single phase AC supply is given. Here is a DPST, means a double pole single throw switch is there. Here fuses are connected. Ammeter, voltmeter are shown. Ammeter measure the total motor current, voltmeter measure the voltage across the motor. In this practical, digital meters are inbuilt in the panel. For power measurement, one wattmeter is connected, and this is the capacitor start and capacitor run induction motor. Here capacitor start, induction run induction motor is shows because the centrifugal switch cuts the A1 A2, means auxiliary winding. This circuit gets cut, and this is the mechanical loading brake and drum arrangement. The resources: single phase induction motor. Here then mechanical brake and drum arrangement for the motor. Ammeter, voltmeter, wattmeter. Ammeter, voltmeter are inbuilt to panel of the machine. Wattmeter is connected. Tachometer for speed measurement. Now the observations required, means first serial number, input voltage should be recorded, input current, then input power W1, means voltmeter reading, ammeter reading, wattmeter reading. These are the digital meters. Then speed, by using tachometer we can measure the speed F1 and F2. These are the forces or balance weight applied to the motor. Here is the calculation part. We have to determine torque is equal to 9.81 into Re, effective radius of pulley, F1 minus F2 Newton meter. Motor output 2 pi nt, means torque is calculated here, divided by 60. Output power is in watt. Motor efficiency W2 upon W1, means motor output is W2 and input is W1. Efficiency, speed regulation, no load speed minus speed on load divided by no load speed into 100. This is the speed regulation. And input power factor cos phi is W1, means wattmeter reading, divided by voltage into current. We are now taking a sample 2 reading. One is a no load reading, second one is a on load reading. First of all, see the resources. This is the control panel for single phase motor with brake load test. Here is a digital ammeter, here is a voltmeter digital. This is the connection already made. This is the capacitor start, capacitor run, single phase induction motor. This is the single phase dimmer stack. Wattmeter is connected here, and this is the capacitor start, induction run, induction motor. Here is the nameplate of the single phase induction motor. Switch on the supply. Here is the main switch. A auto transformer is connected to the main switch, and a wattmeter is connected for input measurement of input power, means motor input. Then here is the supply is given, and accordingly the windings means M2 and S1. This is the starting winding, this is the main winding, means running winding. Here is the capacitor connection. Already connections are done. Now we are going to start. First of all, switch on the supply, then gradually increase the voltage. Here we are giving directly 210 volt. First reading is a motor current is a 2.5 ampere. Input voltage means a 210. This is the wattmeter reading. Wattmeter is connected to high range and 250 pressure coil. Its reading is 75, then 80, 85 watt multiplied by its multiplying factor. This is the wattmeter reading. Now measure the speed at this point. (1499) is the speed. (1499). It is the no load test reading, means speed. Now taking the load test. We are now applying the load forces. Here F1 is a 2 kg, F2 is a 0.5 kg. First of all, F1, F2 is 0. Now 2 and 0.5 kg. Here motor current is a 2.6. Input voltage is a 209 volt, and this is the input power. Now power is a near about 145 watt. Here we will return the input voltage is a 209 volt. Input current is a 2.6. Input power is a 145 into multiplying factor, and speed. F1 is a 2 kg, F2 is a 0.5 kg. Now speed. 1490. 1490 is the speed. Second reading. First reading is now. First reading is input voltage is a 210, input current is a 2.4, input power is a 95 into multiplying factor, speed is a 1499. In this case, no forces, means balance weight applied to the motor, and here wattmeter shows 95 watt reading. Here digital multimeter shows 210 reading. In this way, the first case no load readings are taken. Now gradually decrease the supply voltage, and now see the motor is smoothly goes on stop. Then switch off the main supply. Here is the observations, means we have to determine radius of a pulley brake drum. Its circumference is measured 12.8 centimeter, converted into meter means 12.8 divided by 100, it is 0.128. Now determine radius. Circumference divided by 2 means diameter upon 2, 0.12 upon 2, it's 0.064 meter. Now thickness of a belt is 0.5 centimeter, means it's 5 mm thickness belt, converted into centimeter 0.5 centimeter, converted it into meter 0.05 meter. Now effective radius of pulley, RE effective radius plus thickness upon 2, 0.064 plus 0.05 upon 2, determine it as a 0.089 meter. Here multiplying factor is a 2, hence 95 into 2 190 watt. Here 145 into 2 290 watt. This is the conversion reading of a wattmeter. Now sample calculation is here. Torque 9.81 into 0.089 RE, F100, no load reading or no forces apply, hence torque is 0, its output is 0, efficiency is 0, but speed is a 1419, speed regulation is also 0, but power factor calculated as cos phi is equal to W1 into divided by V into I. W1 is a 190, V1 is a 210, input current is a 2.4, simplifying 0.3769 is the input power factor of first reading. Now second reading, by same manner, force F12, F2 0.5, 9.81 into 0.089, simplifying this, torque is a 1.3096 Newton meter. Then motor output 2.nt divided by 60, it is a 204.34 watt output. Motor efficiency means W1 upon W2, W1 is a W2 is a 204.34, W1 is a input wattmeter reading 290, efficiency is a 70.46, speed regulation is now speed decreases 1419, it is a 0.6. Now similarly, input power factor calculated as W1 reading 290 divided by input voltage 209 into 2.6. By simplifying this, we are getting the input power factor is a 0.53. In this case, the speed is a 1490. Here sample calculation is there. Speed is a 1419. Wattmeter reading is a 290 for second reading, and F1 is a 2, F2 is a 0.5 kg. In this way, we perform the direct load test on single page induction motor, and the results are very accurate. So student may calculate their results in the manual. Thank you very much.